Hi, good evening. Welcome to another episode for our video lesson in Science 10, and our topic is Earthquake Epicenters using Triangulation method. I hope you're still doing great with your module in Science 10, and you can still follow on the topic we are still dealing and answering. So for now, we will proceed to another topic, and this time you will learn the concept of how to apply the triangulation method in locating the earthquake's epicenter. But before we jump on that topic, kindly take a look at the weekly home learning plan for the third week. First, of course, you need to read the objectives, your target, okay? And then, answer, try this. Perform the activity which is entitled Do It, and answer the two guide questions that follow. Do activity number 1, the lag time, as well as activity number 2, how far I'll go. You need to compute for the distance of the epicenter to the station using the chart provided and accomplish the table that follow in that activity. Identify the different parts of the cross-section of an earthquake that is in the activity entitled Do It. And then, after that, you need also to perform another activity entitled The Epicenter. Also, you need to answer, apply what you have learned, and then write the important concepts in your notebook, okay? And lastly, you need to answer the post-test or the assess what you have learned, okay? So kindly take note of the learning task for this week. Now, as for our introductory topic, earthquakes are naturally occurring phenomena caused by the continuous movement of the plates beneath it, or beneath us rather, okay? So in your grade 8 science, you already learned about earthquakes, right? So there were several topics covered for you to understand the concept of earthquake. Scientists are continuously observing its behavior and movement to identify its location. So how do we identify the location of the earthquake? That is actually the purpose of this module. Now, one of the ways the scientists use to locate the earthquake is to locate its epicenter using what we call the triangulation method. So, ano nga ba itong tinatawag natin na triangulation method? Of course, from the term itself, triangulate, okay? So, it involves 3, okay? So, we will try actually to locate the 3 points, okay? But later on, you will be understanding this one, okay? So I will enlighten you on how to perform this triangulation method for you to locate the earthquake's epicenter. Okay. Now, we have learned in your grade 8 science that an earthquake releases 3 types of seismic waves, right? Okay. So we have what we call the primary waves, the secondary waves, and the long surface waves. Okay, so the names are P waves, S waves, and L waves. Now, the first 2 travel in the Earth's interior, okay, while the last one is on the surface. So therefore, based on that, of course, we will just consider the first 2 types of seismic waves. So we have the P waves and the S waves. Since the last one, it travels or propagate in the surface of the earth, okay? Now, these waves travel in different velocities. Of course, when we speak of velocity, that is actually related to the speed of the wave or the seismic wave, okay? So since they differ in velocity, one will arrive first, okay, in a given seismic or recording station, okay? So they do not arrive at the same time. Now, the farther the recording instrument is from the focused, okay, the greater the difference in the arrival time, which will tell us the distance of the earthquake's focus from the seismic recording station. Okay, so this focus is actually the source of the earthquake. So sinasabi lang dito na kapag malayo, okay, yung recording instrument sa focus or sa origin ng earthquake, okay, of course we will expect a greater difference in the arrival time of this seismic waves. You will be comprehending this one as we proceed with our next slide, okay? But kindly take note that the difference in the arrival time of the P and the S wave will tell us the distance of the earthquake from a given recording station, okay? So kailangan natin malaman yung pagitan, okay, ng arrival time ng dalawang waves na to, the P and the S wave, para, okay, makuha natin yung distance ng earthquake's focus doon sa recording station. Now, as for your target, we have two objectives for this lesson. You need to compute mathematically the distance of the epicenter. So, meron tayong formulang gagamitin para mahanap nyo yun, distance ng epicenter sa isang seismic station. And then after that, locate the earthquake using the triangulation method. So that's our target. I want you to answer this, try this activity or the pre-test. Okay, so this is just a 5-item test. What is the study of earthquake and seismic waves that move through around the earth? What are the waves of energy caused by the sudden breaking of rock within the earth or an explosion? What is the wave that can travel through the earth's inner layer? What is the fastest type of seismic wave that arrives first in the seismic station? And what is the second wave you feel when there is an earthquake? So answer that 5-item pre-test, and then after that we will check. Okay, so the answer for the first item is, of course, this is a study of earthquake. We call it as seismology. For the next item, the answer is seismic wave. That's what we call the kind of waves of energy caused by the breaking of rock. For the third item, we have what we call body wave, which can propagate or travel in Earth's inner layer. For number 4, that's a B. That's primary, the fastest type of seismic wave. And then for number 5, that's letter D. That's secondary wave or the S wave. So how many scores did you get? I hope you got 5. But even you receive a low score, that's still okay. Now let's proceed. Okay. So we are still discussing this plate tectonics, right? So actually this is the coverage for quarter 1, more on the plate tectonics. Now you learned that plate tectonics, it involves the study of this part of the earth, or specific sphere, what we call lithosphere, wherein it is actually the rock part of the earth, or the land part of the earth. Now, plate tectonics is very essential in understanding how and why several features of the earth continuously changed. Okay, so this change actually gives the events, okay, kung bakit tayo nagkakaroon ng mga tinatawag natin ng mountain ranges, volcanoes, earthquake belts, and others po. Okay? So yung mga pagbabago na to, this leads to the certain events na nabanggit dito sa part na to. Okay, so I guess you're familiar on this, that lithosphere is made of a crust, not only crust but the upper part of the mantle. Crust is made of a variety of solid rocks with an average density of 2.8 gram per cubic centimeter and thickness that ranges from 5 to 50 kilometer, on which there are two kinds. We have what we call the continental crust. It's thicker but less dense, and we also have what we call oceanic crust, which is relatively thinner but denser. Now, plate tectonics, okay, you also need to understand what we call the plates or the tectonic plates, wherein the Earth's crust is broken into several units, and we call them as plates. They move independently of from one another rather, okay? So walang pakialam actually yung isa. So iba-iba yung movement ng bawat isang plate, okay, from one another. We also discussed here in our previous topic, okay, the 7 major plates, namely North American plate, South American plate, Eurasian plate, African plate, Indian plate, Pacific plate, and Antarctic plate. Again, this red line actually signify the plate boundaries. We call them as plate boundaries. Now, there are numerous microplates also that includes the Philippine plate, okay? So, medyo maliit sila kumpara doon sa mga major plates na tinatawag. Now, in terms of the movement of plates, again, we already discussed this, that the plates move very slowly but constantly. We call this movement as tectonic, okay? So again, when we speak of tectonic plate, it's simply the movement of plate from one another. Okay. Now we jump now to the concept of earthquakes. How do we locate earthquakes, and what you need to know when you try to locate earthquake, okay? Okay, so makikita natin dito sa picture, meron tayong isang diagram or representation. So we will try to go over with this. But as mentioned, there are different types of seismic waves, right? The P waves. Okay? So for P waves, that is actually the waves that vibrate parallel to the direction of the movement. Okay? So hindi natin to actually nakikita, right? But okay, in terms of movement, this is how we illustrate primary waves. So yung primary waves, you try to imagine the movement of a slinky when you try to push and pull it. Okay? So, di ba nakapaglaro naman kayo ng slinky or yung mga toy spring nung bata pa kayo, di ba? Wherein, if you move the slinky on that direction, okay? So, it propagates also going to that direction. Okay? So, here, we have what we call parallel kasi yung direction ng movement is parallel doon sa vibration. Okay po. So, kapag yung slinky ginalaw natin on that direction, we try to vibrate it, the propagation is also going to that direction. So, that is actually the concept of this parallel po. Okay? So, that's a primary wave. Aside from that, primary waves travel faster. It travels through solids, liquids, and gases as well. Okay? Kaya siya tinawag na primary. Okay? Kasi, yun na nga. They travel faster. On the other hand, we have what we call the S wave, wherein it is actually being portrayed in this diagram. Okay? But, S wave is also known as shear waves, wherein the vibration is side to side to the direction the wave moves. Okay? So, ano ba ang ibig sabihin nito? Kung yung isa parallel, this one now is perpendicular. Perpendicular. And when we say perpendicular, because if you will try to see this picture here, diba? Okay, so parang slinky din siya, but in a manner na when you move the slinky up and down, okay, up and down, diba? Parang ginaganyan mo, meron siya makikreate na waves na ganito. So the propagation proceeds on that direction. Okay, so again, the vibration is parallel to the direction of the wave, and that's what we call secondary wave. Now, this wave is lower than P waves. Mas mabagal siya. Kaya nga siya tinawag na secondary. Now, it also travel through solids. Okay? So, they travel in solids, but solid material only. Unlike with the first type, which is P wave, all solid, liquid, and gas, they can penetrate or they can propagate. Now here, we can actually see what we call seismograph or seismograph. So what is a seismograph? Seismograph is a device that is used in order for you to record the vibration which was caused by the earthquake. So basically, it's a device used to locate the earthquake. Okay? So isa siyang instrumento ginagamit ng mga seismologists para hanapin kung saan ba nag-originate yung earthquake na yan. So that's seismograph, okay? So it's a sensitive instrument that can detect, amplify, and record ground vibration, even those too small to perceive by human beings. Okay. On the other hand, we have what we call the seismogram, which is a graph showing ground motion versus time. Okay. So ulitin natin ha. Itong isa, which is the seismograph, it's an instrument. Seismogram, it's a graph. Okay? So magkaiba po yun ha. Never interchange these two term or two concept. Okay? Kasi madalas nalilito or nakakalimutan na yung isa ay instrument, yung isa ay just record from or generated by that instrument. Okay. Now, for the first activity in your module, you need to accomplish this do it part. Paano ba siya sasagutan? Okay? So, ito, nandito, this is a picture. Okay? This is the picture, actual picture na pwede din natin tawaging seismogram. Okay? Okay, kasi this is a record. It's a graph that shows the detection of seismic waves. Okay? Nagaling doon sa seismograph. Okay. So, observe that. Okay? So, here in the x-axis, you can see the time represented in seconds. Okay? So, after studying the picture, you need to answer these two questions. Okay po. So, number one, among the types of wave which is detected first in the seismograph, alin yung nauna? P, S, you can also consider this ground motion. With regards to this time, alin yung naunang nakarating? Okay, so we will answer that. Actually, even without this graph, you can answer question number one, di ba? Kasi nabanggit na natin, ano ba yung mas mabilis na type of wave? Pangalawa, what is the interval between the P and the S wave. Okay? So, ano ba ang interval time sa pagitan ng primary at ng secondary? Paano siya malulocate? Okay? So, all you need to do is consider this one. So, ito yung P wave natin, diba? Ito yung S wave natin. Okay? So, kailangan nyo lang i-estimate yung point kung saan nagsimula na na-detect yung primary. Let's say, meron ditong shaking, diba? Kasi meron siyang konting pag-akyat. So, here is the detection of the primary wave. While on this side, meron tayong detection ng secondary wave. So, ang tinatanong sa number 2 is simply yung interval time sa pagitan ng primary at ng secondary. So, paano natin yan ma-account? Of course, you need to try to consider itong graph na to. Okay? And try to locate the interval time. Okay? So, itong part na to, parang, let's say, mga ilan kaya to? If this is 15, this is 10, of course, the middle is somewhat 12.5. So, siguro dito is mga, let's say, 11, ba? Okay? Dito naman is parang similar din yung pagitan, but this time, this is, let's say, mga 21. Okay? So, 21 minus 11, that gives us, okay, 10, right? So, 10, ano? What's the unit? Of course, we have 10 seconds. Okay. So, yun yung actual answer ng number 2. So, yung interval time is 10 seconds only. Now, for this activity number 1 in the explore part, you will be doing the same thing po. Okay? So, kailangan nyo gamitin itong chart sa taas, para masagutan nyo yung table na nandito. Okay, meron na example. Yung data with regards to the Chicago. So, meron tayong 4 na recording station, namely Chicago, Kansas, Santa Barbara, and the Seattle. Okay? So, ito yung kanilang seismogram. Okay po. Okay? So, yung sa Chicago, kung titingnan natin, di ba? Okay? Itong part na to. Okay? Itong part na to. That's the recording of the recorded arrival of the primary wave. So, kung titingnan natin sa baba, you will try to estimate that is 18 seconds. Okay? Still, in the Chicago, meron na naman tayong recording ng isa pang type of wave. So, this time, we call this one as the secondary wave. Okay? Wherein the arrival time is, let's say, mga 153. So, ano yung tinatawag natin na time difference? Okay? Or pwede din natin siyang tawagin na lag time. How do we get that? We simply get the difference between the S and the P. 153 minus 18, that gives us 135 seconds. Okay? So again, gamit lang po itong graph na nasa taas, sasagutan nyo yung table na to. Okay? Bigay yung pagdating ng P wave at ng S wave in terms of seconds, and then get the lag time. Okay. Now for activity number 2, how far I'll go, you need to compute now for the distance of the epicenter to that to the different stations. Okay? So, paano siya ma-compute? We have this formula. Take note of this formula. Okay po. So, tandaan po to. Itong formula na to because it's very important. we will keep on mentioning this formula. D is equal to TD divided by 8 seconds times 100, wherein D is the distance in terms of kilometer, and TD is the time difference in the arrival time of P wave and the S wave in terms of seconds also. Okay? Take note that 8 seconds and 100 kilometer are constant. Meaning to say, kailangan nyo na lang i-retain yung mga values na to. Later on, I'll try to explain kung bakit ba. So, bagay galing yan 8 seconds and 100 kilometer na yun. Okay? But for the meantime, let's try to accept that this formula is valid in computing for the epicenter of the earthquake, okay, recorded in the different station. Okay? So, how do we get the distance of the Chicago as one of our stations? Okay? So, again, we try to use this formula. Okay? So, time difference, nakuha na natin to kanina, and that is also the lag time, and that is 135. Okay? So, yung 8 seconds, ulitin natin, nandyan na yun sa formula, yung 100 nandyan na. So, yun lang po. Okay? So, yung lag time or yung time difference, i-divide ng 8 times 100, yun yung distance in terms of kilometer po. Okay? So, we have now 1,687.5 kilometers. So, ano bang ibig sabihin nito? Ito yung distansya ng Chicago, yung first station natin, doon sa epicenter ng earthquake. Okay? Na na-detect ng seismograph. You will also do that in other seismic stations or recording stations. Just do the same process, but this time, of course, they'll be having a different lag time. Okay. So, take note, again, nabanggit na natin yung 3 types of seismic waves. But, of course, we will just consider the first 2 types of waves, the P and the S. Okay? So, to determine the distance, you need the interval, time. Okay? You need the interval time between the P and the S wave. You need to subtract their time difference. You need to subtract the arrival time of the S and the P wave to get their time difference. And of course, the time difference will be used to determine the distance of the epicenter to the recording station. Okay? So, you need to divide the lag time by 8 seconds, then multiply it by 100 km. Okay? Ito na po yung explanation kung bakit yung 8 seconds and yung 100 km are constant values. Okay? Because experimentally, they have found out that 8 seconds is the actual time or the time difference between the arrival time of the P and the S wave kapag meron tayong distance na 100 km from a given station. Okay? So again, you need to remember this formula. Okay. Now, for the activity, ito na po yung another activity, apply what you have learned. Okay? So, you will try to perform this one. So, again, the same lang ng previous activity. You will try to record the arrival time of P wave, the S wave, get their difference for you to get the lag time. Apply the formula to get the distance of the epicenter from the recording station. Okay? Ito yung P wave, arrival niya. Ito yung arrival naman ng S wave. And iba-iba kada station po. Okay? But the process is still the same. Yung data lang ng P and S ang nagkakaiba. And then just get the difference para sa lag time and apply the formula by plugging it the value for the lag time. And then divided by 8 times 100. Okay? So you can do that in your activity sheet. Now, another activity is for you to accomplish this one. identify the different parts of the cross-section of an earthquake. Okay? So, meron tayong number 1 to 5. Ito number 1, ano ba to? Itong number 2, ano ba ang tawag dito? Yung number 3, ano ba yung tawag sa point beneath that point? Number 4, ano ba ang tawag dito? Number 5, ano ba ang tawag dito? Okay? So, you have 5 options actually. So, you just need to choose from them. Now, for the activity entitled Epicenter, you will be needing a map, an actual map of the Philippines po. Okay? Since you are not allowed to answer in your module, ang gagawin po is, ito po, pwede nyo siyang i-photocopy or kung meron kayong scanner sa bahay, i-scan or i-photocopy po ito. And then, attach the map, okay, in your tablet paper. Of course, hindi lang basta map, kailangan yung applyan ito na tinatawag natin na triangulation method. Okay? Now, kung wala naman photocopy or scanner in your house, ang gagawin po is i-trace na lang. Okay po, i-trace na lang sa bond paper or sa papel as long as makuha nyo yung itsura ng mapang ito. Okay? Kasi it's a scaled map. Now, according to this activity, you need to locate the epicenter of the earthquake. Saan ba tumama yung earthquake na ito? You will be needing compass. Ano ba yung tinatawag na compass? Yung ginagamit pambilog. Okay? It's tawag lang sa compass na yun. Okay? You'll be needing compass and pencil. Oh, and of course, this map. Okay? So, here, makikita na natin yung mga data po. Okay? So, binigay na yung actual data, yung difference ng arrival time ng P wave at ng S wave. Okay? And then, this is now the distance of the epicenter from the station. So, in the instruction here, you need to center your compass to the station you have chosen. Okay? So, kailangan nyo i-locate nasaan ba yung Batangas? Ito. Nasaan ba yung Puerto Princesa? Ito. Nasaan ba yung Davao? Ito. Okay? And after that, after you try to locate the stations, ang gagawin nyo na is, kailangan nyo nang i-apply yung tinatawag natin na triangulation method. So, ang gagawin nyo dito sa portion na to is, halimbawa, ito yung Batangas, diba? Ito yung Puerto Princesa. Ito yung Davao. Okay? Huwag nyo nang tingnan itong time difference na to. Kasi ginamit lang siya para malocate natin yung distance ng epicenter sa station na to. And then, now, you have here, let's say, 560 kilometer. Okay? Take note, sa mapa, paano nyo ba makukuha yung distance na to? Masyadong malaki, di ba? So, 516 kilometer, that's very far. Okay? So, therefore, ang gagawin nyo is, you will try to have a ruler. Kuha ka ng ruler. Okay po. In the ruler, you will try to somewhat do scaling or conversion po. Halimbawa, let's say 100 kilometer. For every 100 kilometer, you want to represent it in 1 centimeter. Okay po. Kasi yung kilometer, mahirap siyang makita sa mapa na hawak nyo. Kasi nga, kilometer is napakahaba nyo. Okay? So, ang gagawin natin is mag-apply tayo ng scaling na tinatawag. Kung saan, yung 100 kilometer na yon gagawin natin 1 sentimetro lang. Okay? Kasi that is now easily na malocate doon sa mapa nyo using your ruler and compass. Okay po? Okay? So, for example, here in the Batangas, kung meron kang 560 kilometer, how many centimeter is that? Okay? You know that it's 5.6. This time, it's 5.6 centimeter. So, kukuha ka ng ruler, okay? From that point, magme-measure ka ng 5, let's say 5 centimeter. Let's say, ito na yung 5 centimeter. Okay? And then, using your compass, lalagay mo dito yung parang metal part, and then yung part ng lapis, and then ikot mo siya. Okay? So, that is the point for the Batangas. Okay po. Okay? That's not actually. Halimbawa, extend natin. Ito yung 5.6 centimeter. We'll try to come up with a circle. Example lang po, kailangan bilog talaga siya. For Puerto Princesa, you will do the same thing. So, yung 400, let's say that's 4 centimeter, right? Okay. So, ano ba? Ito yung 4 centimeter. For Davao, that is, let's say, Davao is 480. So, let's say, nandito. Okay po. So, meron ka makukuhang 3 bilog dyan. But take note, hindi po to yung actual kasi nga ako lang gumawa nun. But the point is, you just need to get the point of intersection. Okay? Kung meron kang 3 bilog, ano ba? 1, 2, and 3. Kunin mo yung point kung saan sila nag-intersect. Okay? So, yun yung pong gagawin sa mapa. You will try to draw in your map and try to locate the point of intersection. Yung point of intersection na ito, yun na yung tinatawag natin na epicenter. Okay. So, pinaliwanag siya dito sa keep this in mind. Just try to read on this. Baka siya tinawag na triangulation method kasi gumamit tayo ng 3 data sa magkaiba-ibang 3 seismic stations. Okay? So, at least 3 seismic stations po. Okay? Bakit 3? Kasi kung 2 lang yan, mayroon tayong 2 bilog. Okay? Meron tayong napakalaking area. Okay? To the point na meron tayong 2. So, nasaan dito yung tinatawag natin na epicenter. But, kung meron tayong 3, may-narrow down natin siya at a certain point. So, that's the logic of the triangulation method. Okay? So, you will do the same thing for this. Apply what you have learned. Get the distance now. Okay? Paano siya makukuha? Kailangan natin gumamit ang formula and then substitute yung time difference and try to scale using this point. Iko-convert mo lang. Halimbawa, nakakuha ka ng let's say 2,000 kilometer dito. Now, you know, na binigay dito na for every 1 centimeter or for every 1,000 kilometer, that's 1 centimeter. So, kung meron kang 2,000 kilometer dito, of course, ang answer mo dito is 2 centimeter. Okay? And try to draw that one using your compass and pencil and rulers. Okay? So, just be familiarized with this term. Memorize po to. Nabanggit na natin siya, but can also take down this. And then, let's now proceed to the last part. Okay? Assess what you have learned. So, sasagutan nyo yung 5 tanong na nasa module, last part ng module nyo. Which is the correct sequence of events na kailangan nyo i-follow when you locate the epicenter of the earthquake. You're provided with the data showing the arrival time of the P and the S. Ano ang makukuha nyo kapag meron arrival time ng P at ng S? And from the seismogram, the distance to the epicenter can be determined by, okay, for number 4, ito po yun. What is the distance of the epicenter from a certain recording station? Okay, so meron tayong arrival time na 1 minute and 10 seconds. For number 5, locate the earthquake epicenter. Locating that one is important because it will pinpoint blank. So you will be given a few minutes to answer that. Okay, just 5 items to test your understanding. Now, let's try to check. Ano yung sagot sa number 1? Ano yung correct sequence? Of course, that's letter B. 3 muna. Kailangan ng data sa 3 stations. And then, kukunin mo na yung difference ng arrival time ng P at ng S. And then, makukuha mo na yung distance ng epicenter. And then, apply the triangulation method. Next, kung meron kang data ng arrival time, of course, you can locate the epicenter. Next, ulit lang, the distance of the epicenter can be determined by getting the difference in the arrival time. For number 4, how do you get this? Okay, how do you get this? Take note that the distance of the epicenter is equal to time difference divided by 8 seconds times 100 kilometer. Now, 8 is in terms of seconds, 100 is in terms of kilometer. So, ano yung time difference dito? That's 1 minute and 10 seconds. We know that in 1 minute, we have 60 seconds, right? So, add that to 10 seconds. That will give you 70. So, 70, that's 70 seconds. Yan na yung time difference. Okay? So, that is 70 divided by 8 times 100. The result is 875. Okay? So, that's how you get the distance. And for number 5, important yung malocate natin yung epicenter because it will pinpoint what we call the fault line. So, importante din malocate yung fault line para paghandaan yung mga earthquake or yung mga sakuna na dulot ng earthquake po. Okay? So, yung mga fault line na yun yung nagsisignify na meron breakage or paggalaw ng mga lupa. So that's it. That's our discussion with the triangulation method para malocate natin yung point of intersection. Okay? So yung intersection na yun yung tinatawag natin na earthquake's epicenter. Itong tatlong red na to, yun yung seismic station natin. Okay? So that's what we call triangulation method. So the importance is that when we pinpoint the earthquake epicenter, we can also locate the fault lines that are active. Okay? Kasi pag nalocate mo ito, malolocate mo yung focus, and of course, when we locate the focused, malalaman natin yung tawag natin na fault line. Okay? So that's it. Thank you for listening. I hope you understand now the triangulation method. See you next week. Bye-bye.